Okay, turn to the third page of AZMerit Review number 3. And in 1 through 4, we are asked to solve for the missing variables. If you have 3 variables, write it as an ordered triplet. If you have 2 variables, write it as an ordered pair. We're going to use a calculator to make this easier. So I'm going to take and write this right now as one matrix. So I'm going to write 3, 2, 5, 2, negative 1, negative 3, 4, 3, 5, and 11, 4, negative 1. All the x's, all the y's, all the z's are already organized, and the answer's in the back. Now this is a 3 by 4. 3 rows, 4 columns. Then grab your calculator and do second plus 7, 1, 2. And you're going to hit second matrix. So second matrix, we're going to edit A. We know the dimensions are 3 by 4 because there are 3 rows and 4 columns. And I'm going to plug in what I have. So going straight across, 3, enter, 2, 4, and 11. 2, negative 1, 3, 4. Make sure you're plugging in these correct. One wrong number and you will have the wrong answer. Okay, once you've plugged everything in, you're going to do second quit. Second quit. We want to go back into matrix, second matrix, and we want to go to the math, and we want to find R, R, E, F. And we want to go back and get the matrix we previously did, so second matrix. A is highlighted. Press enter. And the numbers in the final row are going to represent your x, in this case your y and z. So x is negative 3, y is 2, z is 4. Now if you're unsure if you did this right, we can plug it in just to make sure. So negative 3 times 3 is negative 9. 2 times 2 is 4. 4 times 4 is 16. When I calculate this, I should get 11. So negative 9 and 4 is negative 5, negative 5 and 16 is 11. And I could do that for each one of these, and you would see that when I substitute in the x, y, and z, I end up with 4. Substitute x, y, and z, I end up with negative 1. Okay, so my ordered triplet is negative 3, 2, and 4. Moving on to number 2. As you notice that this is in a different form than number 2 is in, so I need to reposition these numbers and variables to look like this. I need the x's and y's on one side and in alphabetical order, and the numbers or the constants that are by themselves on the back side. So I'm going to move this x over. When it comes over, it becomes positive. We already have a positive 1y. And now I'm going to take this negative 1, this constant, and move over. And the negative 1, when it goes across the equal sign, it becomes a positive 1. Again, whenever you cross over the equal sign, you change sign. That's why this becomes positive and this becomes positive. Alright, I'm going to bring the x back over. It was positive. When it comes over, it becomes negative. We already have a positive 1y. And we have a negative 4 on the opposite side. So writing down the numbers, I have a 4, 1, 1, negative 1, 1, and negative 4. 2 rows, 3 columns. 2 rows, 3 columns. Second plus, 7, 1, 2. We're going to go second matrix. And we're going to edit A. Again, this is a 2 by 3. How do I get that? 2 rows, 3 columns. Press enter, and I'm going to plug in the numbers that I have. 4, 1, 1. Negative 1, 1, negative 4. Do second quit. Second matrix. Go to the math and find R, R, E, F. Press enter. Second matrix. Press enter for A. And when we press enter again, whatever's on the far right hand side represents your numbers, and they're going to be in alphabetical order as long as you set them up like that. So your first variable is x. That means x is 1 and y is negative 3. This ordered pair is 1 and negative 3. Okay, number 3 is going to be like number 1. So I already have x, the y, the z's. So you know what? There's 3 rows and 4 columns. I'm not going to take time to rewrite it like this. Second plus 7, 1, 2. Go second matrix. Edit. We need to identify what the dimensions are. Once again, 3 rows and 4 columns. This was taught to you by your term 1 teacher when I was on maternity leave. So now I'm plugging in -4 going straight across 6, -1, and -34. Second row, -2, -5, 8, and -9. Last row, 5, 2, -4, and 33. Okay, so we've defined our matrix A. We quit out, and now we go second matrix. Go to calculate, or go to math. Find RREF. Then second matrix. Make sure A is highlighted. Press enter. And again, it's going to be in alphabetical order because it was set up in alphabetical order. So this is your X, Y, and Z. X, Y, and Z. Lastly, this one's going to be a little bit easier than number 2 because we already have the X's and Y's on one side of the equal sign and the constants on the opposite side. So this is a 2 by 3. Second plus 7, 1, 2. Going to hit second matrix, edit A, define the dimensions, 2 by 3 for 2 rows, 3 columns. And now we're going to plug in what we see. -3, -4, -2. 1, 2, 3. Quit out by hitting second quit. Second matrix, go to math, go down to RREF. Second matrix, A is highlighted, press enter and enter again. Because the problem was set up in alphabetical order, this represents your A and this represents your B. Excuse me, I meant to say this represents X and this represents Y. So X and Y, and written as an ordered pair. Now 5 is the same concept, but we are going to apply it to an application problem. So Karen, Mary, and Jane go to a Chinese restaurant for lunch and order 3 different lunch combination platters. So Karen orders something, Mary orders something, and Jane orders something, and we have the class. So we're gonna have Karen, then next is Mary, and last is Jane. So I'm gonna have what they ordered, and then I'm gonna have the cost. Okay, so Karen orders 2 portions of fried rice, 2 portions of fried rice, 1 portion of chicken. Okay. Mary orders 1 portion of fried rice, 1 portion fried rice, 1 portion of the chicken, and 1 portion of the sauteed broccoli. Jane orders 1 portion of sauteed broccoli, 2 portions of chicken. Okay, and so Jane ordered 0 fried rice, and Karen ordered 0 sauteed broccoli. Now, how much did the stuff cost? Karen's cost $5, Mary's cost $5.25, and Jane's cost $5.75. We want to know in the end, how much does chicken chow mein cost? So when I look right at this, I have a 3 by 4. Instead of having X, Y, Z variables, I have F, C, S that I chose to represent fried rice, chicken chow mein, and sauteed broccoli. Alright, so let's go in here, clear everything. Second matrix, we're going to edit A. It is a 3 by 4. And we're going to plug in the numbers that I see. So I see 2, 1, 0, 5. 1, 1, 1, and 5, 25. 0, 2, 1, and 5, 75. So I've programmed right now what the matrix looks like, and now I'm going to quit out. Okay, now we're going to go back in. second matrix. We go down to RREF, second matrix, and this represents, in order, F for fried chicken, the cost of one portion of fried chicken, the cost of one portion of chicken chow mein, and the cost of one portion of sauteed broccoli. Well, this particular question says how much does one portion of chicken cost? $2 for one portion of chicken chow mein. All right, moving on to factoring. You'll notice it doesn't say factor and solve, but we are going to talk about what that would look like as well. So factoring, so we're looking at, remember there's multiple methods and you may use whatever method works for you. I'm going to stick with reviewing using the bottoms up method when appropriate. Okay, so 3 cannot be factored out of all 3 terms. So I'm going to go, what multiplies to give you 18? Which numbers multiply to give you 18? And add to give you 11. And the answer is going to be, let's see, not 1 and 18. 2 and 9 work. So x plus 2 and x plus 9. Now because the leading coefficient is not 1, we need to do bottoms up. This cannot be reduced, so I push it up. This can be reduced. So if it only says factor, there's your final answer. But as a review, if it said solve, and this was set equal to 0, then one answer would have been x equals negative 2/3, and the other answer would have been x equals negative 3. Number 7. Alright, so I can take a 2 out of both of these. I can factor out a 2. I can also factor out the maximum number of x's is 3. So I'm left with x to the 4th because there's 7 x's minus 16. Alright, so notice that this is a perfect square and 4 can evenly be broken down. So 4 can be broken down into x squared and x squared. And since this is a perfect square, one will be positive 4 and one will be negative 4. It is essential that this is a subtraction to do that. Now we're not quite done yet. Can't be factored any further, can't be factored. This can, because I have subtraction, can evenly be broken up, and this is a perfect square. X plus 2, x minus 2. Okay, this would be your factored form. That was the first unit when I got back from maternity leave in October, so it's been a while, but this is your factored form right here. Now what if they would have said solve? Okay, well if they would have said solve, we can see one answer is x equals 2, one is negative 2. Now the only thing to make this group equal to 0 is if this was 0. So x equals 0. Now this is a little more complicated, definitely within your ability. Just needs a little review, so I'm going to take it and set it equal to 0. That's the same thing I'm doing here to get these answers. I subtract 4 to the opposite side. But when you take the square root, you're like, hey, I can't take the square root of a negative. That negative has to come outside and be an I. 2 answers, that's why we have plus or minus. And square root of 4 is 2. So the answers, if it did say solve, would be 2, negative 2, plus or minus 2i, and 0. Okay, hopefully you recognize this. This is going to be your difference, sum and difference of cubes. So I know that 125 breaks into 5, 5, 5, x, 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 and 6, 6, 6. Taking 1, 5, 1, x, and 1, 6, and the symbol that you see, this will always be addition, and this symbol will always be opposite of what's in front. I have 2 5s left, that gives you 25, 2 x's left, that's x squared, 2 6's is 36. How do we get this? Well, if this is 6 times 5 is 150. So you have to say 5 times what equals 150. Just as review, 6 times 25 is 150. So 5 times 30 is 150. 5 times 30 is 150 as well, and it needs to be an x squared. I already have one x. I'll place a second x in that position. Okay, there's your factored form. Now, if they asked you to solve this, one way would be to set this equal to 0, add 6 to the opposite side, and one answer would be x equals 6/5. Now, this portion, you will always have to use the quadratic formula to solve. So you plug that in and get your answers, your two answers. You always have to use for the trinomial and back the quadratic formula. Number 9. So I'm going to test this to see if I can do factoring by grouping. So this is where we did like the midline or half court, 50-yard line. What can I take out of both of these? An x squared. You'd be left with x subtract 2. I'm going to copy and paste that x subtract 2 and back. Put a question mark there. Is there a number I can take times x and get 9x? Yep, positive 9. Is positive 9 times negative 2 equal to negative 18? It is. Okay, what they both have in common is an x minus 2. What's in front of the first and what's in front of the second. So this is the factored form. If they said to solve, as a review, the first part would be x equals 2. The second part would be positive negative 3i. The negative sign comes out and becomes an I. We have two answers, and the square root of 9 is 3. Okay, number 10. First I'm going to see, can 3 divide nicely into 192? So I grab the calculator and see, can I divide a 3 out? And you can, it's 64. So I'm going to take a 3 out of both terms. And now can I take this any further? Well, I know I can break up x to the 4th into x squared and x squared. And I can do this also because I have a subtraction, so one's positive and one's negative. The square root of 64 is 8. This is your factored form. If they said to solve, you'd set each one of these equal to 0 and get answers. So it would look like this, x squared plus 8 equals 0. So x would equal positive and negative I square roots of 8. And remember, we can break down 8 into 4 and 2. So 2 answers, square root of 4 is 2, 2 square root of 2. This would be if they said solve. This is the factored form. Alright, so I can break up x to the 4th into x squared and x squared. And 81 breaks into 9 and 9 evenly, and 16 breaks into 4 and 4 evenly, with one being positive and one being negative. This can't go any further because there's addition. This can go further because we have not only a subtraction, the x can evenly break up into 2, and 9 and 4 are also perfect squares. And if they asked you to solve, you'd set each one of these equal to 0. You would get for this answer some I answers, 2 I answers or imaginary solutions, and then you'd have x equals negative 2/3 and x equals positive 2/3. Flip to the back. Number 12. Same thing, factoring by grouping. I'm going to make my little line here down the middle. I can take a 10 out of both of these and an x squared. I'd be left with x plus 2. So I'm going to copy and paste the x plus 2. What number times x gives you x? And is that same number times 2 equal to 2? The answer would be 1. They both have an x plus 2 in common. Here's in front of the first and in front of the second. it's only telling us to factor, I'm going to stop right there. Number 13, both even. So in my mind I'm like, okay, let's try taking out a 2 once. We're left with 25x squared minus 16. Because I can equally split up an x squared into x and x, I have subtraction and 2 perfect squares. This breaks into 5x plus 4 and 5x minus 4. Again, if they asked you to solve, you'd set each one of these parentheses equal to 0 and solve. Alright, this looks like a little more difficult. So we're going to go back to the bottoms up method. And if you have another method for factoring trinomials, that works as well. What multiplies to give you negative 40 and adds or subtracts to give you a positive 32. That's going to be a positive 40 and a negative 1. So x plus 40 and x minus 1. Now notice that's an x to the 4th. So I need to split up x to the 4th evenly into x squared and x squared. Also notice that the leading coefficient is not 1. So bottoms up, 4 needs to go on the bottom. So this simplifies x squared plus 10 and x squared minus 1/4. And I can push this up. So x squared plus 10 and 4x squared minus 1. Now this cannot be simplified any further. Although it's an x squared, there's no subtraction. This is not a perfect square. But your second parenthesis involves an x squared, which can easily be divided up equally, a subtraction, and 2 perfect squares. Breaks into 2x plus 1 and 2x minus 1. Number 15 asks for synthetic division. So there's 2 ways to do this. One was to do the long division. Some of you were pretty good at it and some of you struggled. So one way was to do the long division. But with synthetic division, I also introduced you to the MAMA method, which stood for multiply, add, multiply, add. So we do an upside down division bar. And now we have to represent the highest exponent is to the 3rd, 2nd, 1st, and 0. So 1 belongs to x cubed. There's no x squared, so it's a 0. Negative 7 corresponds with x to the 1st, and your constant is negative 6. Up here, what makes this equal to 0? It'd be positive 2. Okay, so I'm going to do the MAMA method. Again, it's been months since you've reviewed this. We bring down the first number. And now we start MAMA method. Multiply to get 2. Add straight down to get 2. Everything multiplies back to this number. Multiply to get 4. Add straight down to get negative 3. Multiply to get negative 6. Add straight down to get negative 12. Now how do we write this? Okay, this is part of our remainder. This is part of our remainder. So we have, this is your constant, your number with the x and your cube. So 1x squared plus 2x minus 3 minus 12 over x minus 2. There's a leftover. This is not evenly divided into this polynomial. Same concept. 1 for x cubed, nothing for x squared, negative 14 for the x, and 8 for the constant. What makes this equal to 0 is a negative 4. Bring down the first number before you start the MAMA method. Multiply, add down. Multiply, add down. Multiply, add down. Hey, this time it works out. It divides in evenly. So this is your constant. This contains an x and an x squared. And our last problem of this section. What makes this equal to 0? A positive 2. Again, we have an x cubed. There's no x squared. and x to the first and a constant. Bring down the first number. Multiply, add, multiply, add, multiply, add. So this is our leftover remainder. Constant contains an x and an x squared. 1x squared plus 2x plus 0 plus 3 over x minus 2. Not necessary for you to have a 0 if you don't want to. So we're going to go into number 18. Number 18. Find the real zeros. Okay, I know at most there's going to be 4 real zeros. At most 4. Okay, so let's do second plus 7, 1, 2. Alright, so I'm going to start by plugging this in. X cubed, make sure to use your parentheses, plus 2x squared minus 11x minus 12. Okay, now to me it looks like there's probably a 3, a negative 1, and a 1, 2, 3, 4. Looks like the answers are going to be 3, negative 1, negative 4, but I want to make sure that's right. So second trace value, let's check. Yes, negative 4 is a solution, a 0, a root. Second trace value, negative 1. Yes, negative 1 is a solution, a root. A 0. And our last one is 3, and that also works. So the solutions are in any order. Those are your solutions. Okay, so at most we're going to have 4 here. At most 4 real. So I'm going to come back up and we're going to do x to the 4th minus 5, x to the 3rd plus 7x squared plus 3x minus 10. Okay, it looks like I'm going to have one nice one and one not so nice. So let's check out negative 1. Negative 1 does work. Okay, so I know negative 1 works. This does not appear to be as nice. Let's find the 0. So I'm going to come along here, left bound, right bound above it, and back to the guess. Oh, and x equals 2. Okay, so I'll have 2 real solutions and 2 imaginary. It says find the real 0, so I only need to identify these 2. Okay, continue doing that for 20 and for 21, please. And then back on to 22 and 23.